This video we're going to talk about unit or dimensional analysis, where the idea is that we want to cancel the units that we have and replace them with ones that we want. So whenever possible, I recommend that you start with the end in mind. That is, think about the units you need to end with. That often helps. Sometimes we can't quite because it might be a complicated problem, but when possible I try to do that. So let's start with a simple example. And suppose we want to change 1,000 feet per second into miles per hour. So I'll say like X miles per hour. So how can we do this? Let's break this down into pieces. So I know that I need miles per hour, which means my feet need to become miles and my seconds need to become hours. But they're not going to do that directly. Instead, we're going to do this by canceling units. And that's what I want you to think. We're going to cancel units. So let's change feet per second into miles per second. Let's just do that thing. That is, let's change our feet to miles. So to do that, we're going to multiply by something that has feet down there in the denominator. Now, why would we want to do that? It's simple, because now feet will cancel. Just like x over x is 1, except when x is 0. Feet over feet cancels and goes away. And then I need miles up top, so I'll put miles. And we need to find the conversion factor between miles and feet. Well, I know that there is 1 mile in 5,280 feet. So we're already halfway there. Now we need to change our seconds to hours. Once again, we're not going to do it directly, but we're going to multiply by something. This time we want seconds in the numerator. Why is that? Because now second over seconds will cancel. And I need hours in the denominator, as well as the conversion factor between the two. Well, in 1 hour, there are 3,600 seconds. Notice that what we have now. We have the units left over are miles over or per hour. And then all we need to do is multiply all the numbers or divide all the numbers together. And we get 681.8 miles per hour. So 1,000 feet per second is a little bit less than 700 miles per hour. Let's take a look at another problem here. Maybe slightly more complicated. I think that's what I want to do, is just give a few problems and kind of increase the level of difficulty. So this one, let's change acres to square miles. And how about we have 500 acres? And we want to see how many square miles that might be. So we basically have one unit here that somehow need to end up being miles up there in the numerator, if you would. But can we always get there directly? That is, there some sort of unit or conversion factor between acres and square miles? Well, perhaps there is. I mean, there is, but maybe we don't know that. Maybe we know instead that there is 1 acre will equal 43,560 feet squared. So maybe I can't go directly to acres to miles, but I can go through an intermediary, in this case, feet squared. Now, how should I set up the fraction here? Because we're going to multiply by a fraction. Well, I want acres to cancel. Since it's in the numerator, I want the multiplication piece, or the factor here, to have acres on the bottom so that they cancel. So I can put 1 acre, or 1 acres, just so my words match. In the top, I have 43,560 feet squared. All right, well, I need square miles, not square feet. So let me rewrite this down here, just with the units that we now have. And now I need a conversion factor that gives me miles squared up here. And of course I want feet squared down below like that. And why is that? Again, so that my units will cancel. So how do I get from feet squared to miles? Well, if there is 1 mile is 5,280 feet, then 1 squared, miles squared if you would, is 5,280 squared feet squared. If you need to pause the video to think about that, you might want to do that. Or I can give an idea down here in that I have, if I rewrote it like this instead, like if I had 1 mile quantity squared, like if I split these things up, then I could have 5,280 feet squared. Either way, I get the same answer. And so now I have the units that I need. Because I wanted to end up with miles squared. So all I got to do is multiply through. I'll do 500 times 43,560. And then divide it by 5,280 squared. And I get 500 acres is about 0.781 square miles, or miles squared. All right, let's take a look at other ones that maybe are, there's a little bit more going on. Here's one that's going to involve some hot dogs. All right, suppose we're selling hot dogs. And I know that it costs $1.05 for supplies. And we have a goal. And our goal is that we want to make $81 per hour on average selling hot dogs. So the question is, what do we need to sell a hot dog for on average? That is, what should we charge so that we reach $81 an hour? Now, this $81 an hour is going to be profit. So there are a lot of moving pieces here, and this problem can get really complicated. So let's break it down into smaller pieces. And let's give you one other piece of information. Let's say on average, we sell, let's say, 18 hot dogs. Let's make it complicated, or apparently complicated. 18 hot dogs in 56 minutes. So what should we sell the hot dog for? This is what we're doing on average sales-wise. All right, well, let's start with what we have. That is, we have 18 hot dogs in 56 minutes. Now, what do we want to end up with? That is, remember, this is our goal here. And sometimes just thinking about this will help organize things a little bit better. Especially if I think that in the end, I want dollars per hot dog. So in my mind, I'm thinking I need dollars up there in the numerator and hot dogs in the denominator. But I've been given this to start. So how should I set it up? Well, I'm thinking let's do minutes up top and hot dogs below. Now, why did I think of doing that? Well, because I need hot dogs below. So why don't I just start there? Now, I have a goal of $81 per hour. Even though that's not what I'm trying to find at the end, I'm trying to find dollars per hot dog. But I do have this goal of $81 per hour. So let's change into hours. So I'll put minutes down below because I need minutes to cancel. And then I have hours up top. Like, oh, this seems not quite what I want, right? Seems like something's a little bit off because I want hours down below. But the truth is I have to cancel off minutes, so I got to start here. I'll put 1 hour, 60 minutes. Now, in my head, I'm hoping I can get to what I need pretty quickly. And we'll see in a second if I can or not. If somewhere I have dollars per hour, well, of course I have that. Now, why did I want that? It's because now I could cancel hours. And look at my units. On top I have dollars, and on bottom I have hot dogs, which is exactly what I wanted. And so all I got to do is fill in my numbers. I have $81 per 1 hour. And once again, let's just multiply everything together. So I have 56 times 81. And we'll divide it by 18 times 60. And we get $4.20 per hot dog. Oh, wait a minute. We're almost done, but we have a little bit extra information in this problem. It costs $1.05 for supplies, and I should have put per hot dog. So if I want a profit of $4.20 per hot dog, then I need to sell for $5.25 per hot dog. But the main thing, notice how I'm taking what I've been given, knowing where I'm trying to end up, and writing my units so that I can cancel them so that I get what I want. All right, let's take a look at some classic chemistry problems. Because a lot of people in here doing dimensional analysis are very likely doing some sort of chemistry. Now, suppose that we have some phosphorus. Let's just say it's pure phosphorus. So now we kept it stable. And then we have 158 kilograms of this. And I want to know how many atoms are in 158 kilograms. All right. So I have kilograms, and I want to get atoms. But in chemistry, there's often a hidden quote-unquote step or thing that we need. Here there's two. First one's not that big a deal, but I need to go from kilograms to grams. But I'm not going to go from grams to atom, because that depends. It really depends on the element that we have. So I need to go from kilograms to grams to moles. So you're going to see this is a pretty typical step that we need to go through. Grams to moles to atoms. And since we started in kilograms, we got a little bit extra to do. But let's see if we can do this one. So let's start. I have 158 kilograms. We're going to multiply so that I have grams on top and kilograms on the bottom. Why? Because we can cancel our kilograms. And we know that there are 1,000 grams per 1 kilogram. Now, let's change to moles. And this will depend on the element. So you need to look it up for phosphorus. I happen to look this up a little beforehand. And I want moles up here. And I want grams down below. So I found that there are 0.03229 moles per gram. Or if you like better, we can do 1 mole per 30.97 grams. Please check me. I'm not a chemist. But these are the numbers that I found for phosphorus. Now I can cancel out my grams. I have moles. And I got one more step, which is I need my moles to disappear. And then I need atoms up top. Moles down below so they cancel. Atoms up top because that's what I want. And I know that there are 6.022 times 10 to the 23rd atoms per 1 mole. Now if I do all my calculations correctly, I end up with 3.072 times 10 to the 27th atoms in 158 kilograms of phosphorus.